Hello, this is Mrs. Taylor, and I'm going to walk you through how to solve absolute value inequalities. So when working with absolute value inequalities, there's two cases. There's when you have an inequality that involves less than and an inequality that involves greater than. So we're going to look at both cases. We're going to start with less than. So we have solve each inequality, graph the solution set on a number line. And this is absolute value of 3x plus 4 is less than 8. And so anytime you have an absolute value inequality involving less than, you have to think about the fact that with absolute value, you have two values that are the same distance from zero. So typically you have two solutions. So when you throw in an inequality, you have to think about the fact that there are two numbers that are less than 8 units away from zero. You have the numbers between 0 and 8, but also the numbers between 0 and negative 8. So what we do when we're solving these algebraically is we rewrite our inequality as a compound inequality that reflects the fact that any number between negative 8 and 8 would be less than 8 units on the number line. So what that looks like is I rewrite the inequality I'm given without absolute value bars. So start there. And then the next thing we're going to do is it's almost like a copy and paste. I'm going to take this less than symbol and put another one at the beginning and then put the opposite counterpart of this number at the very front. So I'll have negative 8 is less than this expression, which is less than 8. And so I would rewrite the absolute value inequality to reflect the fact that there are going to be two solutions. So now I just solved this like any compound inequality that I've solved. Whatever I do to one side, I do to the other. So I would start by subtracting 4 from everything, and then I would divide by 3. So subtracting everything by 4 would give me this conjunction, and then dividing by 3 would give me negative 4 is less than x, which is less than 4/3. So now I need to graph that solution set. And so I take my number line and I need open circles at both negative 4 and at 4/3. And 4/3, in case I don't know, I do know that that's 1.3 repeating, but just in case I forgot, I could do 4 divided by 3 in my calculator and get the same thing. So I'm going to have to estimate where that is on the number line. And so I have an open circle at negative 4 and then an open circle at approximately 1.3, which is 1 1/3. And then it's a conjunction. X is greater than negative 4, so that would be to the right. And then x is less than 4/3, so that would be to the left. So it's shade between those two open circles. And so the graph of my solution set would look like this. And if I wanted to test some values, I could plug in some of these numbers between negative 4 and 4/3. Zeros are really easy one to plug in. If I plug in 0 here, I get 0 plus 4, which is 4. Absolute value 4 is less than 8. So I'm feeling pretty confident that that is my solution set. Now that's a case where we're looking at less than. Let's look at an absolute value inequality involving greater than. With values greater than, if you think through it, there are two cases where you have values greater than, in this example, 30 units from 0. If you think about it, any numbers to the right of 30 on the number line will be greater than 30 units from 0. But also, any numbers to the left of negative 30 would also be greater than 30 units from 0. So with greater than, you're looking at a graph that is a disjunction, and so we can rewrite the absolute value inequality to represent that disjunction. So what I do here is I start off the way I started in the previous problem, where I basically rewrite this inequality, but I drop the absolute value bars. And then I also need to account for that second set of numbers that are to the left of negative 30. So I use the word or, and then I rewrite the expression a plus 9 the same way. But now I'm looking at the case to the left of negative 30. So I change the greater than to a less than, and then make the 30 negative. So I flip the symbol, change the sign. And so my second part would look like this. So now I have a disjunction that I can solve instead of working with the absolute value in the problem. And so I'd solve both of these inequalities by subtracting 9. Here I'd get a is greater than or equal to 21. Here I would get a is less than or equal to negative 39. And so this disjunction would represent my solution set for this absolute value inequality. When I graph it on the number line, I'm going to need closed circles because I have some equal to's. And again, with this number line, I'm going to have to estimate where these numbers are because they aren't divisible by 10, which is what the scale is counting by. So estimating where 21 is and negative 39 is may look like this. And then I would need to represent greater than or equal to 21 by shading to the right, and less than or equal to negative 39 by shading to the left. So my solution set when graphed for this absolute value inequality would look like this, representing the disjunction. So that is how you would solve absolute value inequality.